Hey guys, welcome back to the eCoreAcademy e-learning platform. Thank you for watching this video if you're watching this through our website at eCoreAcademy.org. And thank you for viewing this if you're viewing this through our YouTube channel, eCoreAcademy. And if you are viewing this through our YouTube channel, please smash that subscribe button, hit that bell in order to get notified on our latest posts, as well as hitting that like button on this video to help support us. So thank you very much. Today's topic is all about trigonometric ratios, and it's under our course of geometry and under the subject of math. And it's, of course, going to be presented to you by me, AJay Raj. And it's all about looking at sine, cosine, and tangent ratios. So this topic is the first lesson in our geometry course. So I suggest that you view our previous video, or my geometry course introduction, before you view this one. So let's get right into it. So what are trigonometric ratios? Trigonometric ratios aren't only the title of this lesson, but they're also the theme of this lesson. So trigonometric ratios are ratios between the side lengths of right triangles. So let's break that down right here. So it says ratios between the side lengths of right triangles. Notice how I say right triangles here. That's because it's only right triangles. So trigonometry often involves different relationships and ratios between different parts of a triangle. And in this case, it's specifically a right triangle and the ratios between the side lengths. But that doesn't mean that it can't affect any other parts of the actual right triangle. And these relationships and ratios can also be applied in order to understand the relationships between angles in a triangle. So that's also very important, because once you discover these ratios between side lengths in a triangle, you can also determine different measures and relationships between similarity of angles in triangles. And these ratios involve the parts of a triangle that include the hypotenuse, the adjacent side, and the opposite side. So these are all relative sides in the triangle except the hypotenuse, because it's all about choosing the acute angle, a certain acute angle in a right triangle. So let's go into a bit more detail about what I mean by the hypotenuse, the adjacent side, and the opposite side, because these are the three main roles and counterparts that are involved in making these ratios, because it's a relationship between each one, two of the three combined, so that in that manner you get three different ratios, and those are the three different types: the sine, cosine, and of course your tangent ratios. So the hypotenuse in a right triangle, I'll give you a little diagram here. So the hypotenuse in a right triangle is always the longest side of the triangle, and it's the side that's always opposite to the 90-degree angle in a right triangle. Every right triangle must have one 90-degree angle and two acute angles. So there's only one 90-degree angle here, and as you can see, it's the side that's opposite to it. So this is the hypotenuse, and it's C, and it's of course the longest side. And then when it comes to choosing your opposite and your adjacent, those are all relative side lengths, sides of a actual right triangle, because the hypotenuse is always the same. It's always your longest side, but your opposite side and your adjacent side are always interchangeable. So what I mean by opposite and adjacent side, in order to find an actual ratio that you're looking for between side lengths, you have to choose a central angle, an angle that you're describing anything from. So that angle has to be one of two of the acute angles. So it cannot be the right angle. It has to be one of the acute angles. So that's angle B or angle A. So if it's angle A, your opposite side is going to be side A, because as you can see here, an adjacent side is a side that has a touching side or has an opening angle that is in direct contact with an angle. So a side length that has direct contact with an angle, it's one of the opening rays of the angle. And as you can see here, side length B has direct contact with this angle, and it makes the angle. It's a part of the angle. And it's the reason that C is not considered the adjacent side is because it's the hypotenuse, and the hypotenuse always stays as the hypotenuse. So it's the only other adjacent side that's considered the adjacent side to the central angle, and that side length, side B. So therefore, the opposite side of this central angle, the one that's directly across, is length A. So that's how you just determine your adjacent, your hypotenuse, and your opposite. And now all these ratios are dependent on your side lengths, and it's all these ratios between these different legs of a triangle. However, in order to identify three different legs of a triangle, you have to start by looking at one angle. So all of these are relative to an angle or a central point, but we're going to focus on looking at an angle and seeing these different side lengths and then what the ratios create. So of course, this first ratio that we have here is the sine ratio, and the sine ratio is a ratio in a right triangle represented by the opposite side divided by the hypotenuse. And in this diagram, it's relative to A, angle A, and equals A over C, or A divided by C. So what I mean by it's relative to angle A, meaning that we're choosing angle A here in this right triangle, because you can only choose two angles to start from, as you cannot use your right angle in a right triangle. So what happens is if I choose angle A, you're looking for the opposite side divided by the hypotenuse. The opposite side is the side that's not in direct contact with the actual angle and is directly opposite from the angle. So therefore that's side A, and it's divided by the hypotenuse, which is C. So that's equal to A over C. And something that's important to know, the sine ratio is always going to be less than 1, because you always know that the hypotenuse is the longest leg in an actual triangle, in a right triangle. So therefore A would be smaller than C, and it would have to be less than 1. And then our cosine ratio, which is the second ratio, the second of 3, and it's the ratio in a right triangle represented by the value of the adjacent side over the hypotenuse. So angle A is still being referred to as the adjacent and opposite sides are relative, while the hypotenuse is consistent. So that's important to know here. So remember how your hypotenuse is always consistent, so it always stays the same, and the adjacent side is the other adjacent side to the angle. So when we choose angle A here, now we're looking for adjacent side over the hypotenuse. We know that C is the longest leg, and it's the opposite from the right angle of the right triangle. So therefore, that's a hypotenuse. And we're saying that it's the adjacent side that's adjacent side over the hypotenuse that's equivalent to the cosine ratio of the right triangle. So therefore, B is the only other side length or side leg of the right triangle that's coming into contact with the actual central angle of A, and it is not the hypotenuse, which is C. So therefore, it's B over C, or the adjacent side over the hypotenuse. And this is also going to be less than 1, because, of course, C is the largest leg in the actual triangle. So therefore, it's always going to be less than 1. So that's sine and cosine that are always less than 1. However, this next ratio, which is our tangent ratio, it depends on which side is the adjacent side and which is the opposite side, and which one has a larger measure. So it can be more than 1 or less than 1. So the tangent ratio is the ratio in a right triangle that is the value of the opposite side divided by the adjacent side. And in this case, it's very important to identify your central angle, which is represented by the symbol, which is called theta. That just represents your central angle, or the angle that you're focusing on, in order to identify what's the opposite side from that angle, what's the adjacent side from that angle, and what's the hypotenuse, which is always the same. And as you can see here, it's the adjacent side. It's the opposite side divided by the adjacent side. So now this tangent ratio, as I said, it depends on what angle you're using, because if you're taking angle B here, for example, you would have this opposite side A would actually be your adjacent side, and this adjacent side would actually be the opposite side of angle B. However, referring to angle A, as you can see here, it's indicated as the central angle. So side B is the adjacent side, and the opposite side is side A because it's directly across, and it's going to be the opposite side over the adjacent side. So this one's often confused a lot, because adjacent and opposite sides, they can often be confused between each other because they're always so relative. So just make sure you remember it's the opposite over adjacent, and remember that opposite's always on the top. Alright guys, so that was the end of today's video. Thank you for watching this through our eCoreAcademy YouTube channel. Please like and subscribe, and of course hit that notification bell to get notified on any of our latest posts. And I'm so excited to be starting this geometry course, and I hope you guys enjoy this first lesson. Please visit our website at eCoreAcademy.org, and visit any of our socials at Facebook, Twitter, Instagram, and Google Space. So it's been AJ, guys. I had a pleasure making this video, and I hope you guys enjoyed. I'll see you in the next one. Peace.